Hello, everyone. Building on my previous pharmacy inventory management project, today I'm presenting the user experience design and ethical considerations for Pharmacist, an AI-powered system that helps independent pharmacists make smarter inventory decisions while maintaining the highest standards of privacy and ethical responsibility. So let me start with the task analysis. Core problem remains. Independent pharmacists struggle with managing inventory across thousands of products daily. The key task I analyze is the afternoon inventory review and reordering process that happens before close of business. Currently, pharmacists spend probably 30 minutes each afternoon manually checking stock levels, reviewing sales patterns, calculating reorder quantities based on experience, or even just kind of off the cuff, and placing orders with multiple suppliers before the cutoff time and updating tracking systems. My task analysis revealed critical insights. First, the significant cognitive overload. Managing 3,000 plus SKUs mentally is overwhelming. Second, the process is extremely time intensive and it's error prone due to manual calculations. Third, it's frequently interrupted throughout the day, making it even less efficient. Key simplification opportunity is to automate data gathering and provide intelligent recommendations, reducing the pharmacist's decision time from 30 minutes to just 5 minutes while improving accuracy. So for a user experience design, I've created a streamlined afternoon dashboard workflow that aligns with typical pharmacy reordering practices. Near the end of the business day, pharmacists open Pharmacist, review priority alerts, examine AI generated reorder recommendations, and approve, modify, or reject suggestions with one-click actions. System then automatically places approved orders to ensure delivery for the next business day. For the key user interface considerations, first, user inputs and feedback loops. I've designed minimal input requirements with one-click approve, reject, or modify buttons. System learns from the pharmacist's preferences over time and integrates their corrections to improve future predictions. Second, transparency. Every recommendation includes clear reasoning like recommended based on seasonal flu trend up 15%, low current stock at 3 days, supplier lead time 5 days. I use color coded confidence indicators and show historical performance metrics for each product category. Third, communicating uncertainty. System displays confidence scores like 85% confident in this recommendation, provides range predictions such as recommended 50 to 75 units, optimal 65, and shows risk indicators for low stock versus overstock situations. When confidence is low, it presents alternative options. Privacy considerations are critical given the sensitive nature of pharmacy data. We collect patient prescription patterns through anonymized financial transaction data, uh, supplier relationships, and staff decision patterns. The privacy risks include potential patient health information inference or competitive intelligence exposure and regulatory compliance violations. For applicable privacy laws, under HIPAA, we have to ensure that all patient data is de identified before machine learning processes through hashing patient IDs and removing direct identifiers. State pharmacy board regulations, depending on the state, require maintaining controlled substance tracking with accuracy with separate audit trails. Following CCPA and GDPR principles, we implement data minimalization, clear consent processes, and strict data retention processes. Our compliance approach includes technical safeguards like encryption, access controls, and regular security audits, plus organizational measures like staff training and clear data governance policies. For ethical considerations, I've identified three main bias sources: historical bias, where past ordering patterns may reflect systemic inequities, for example, underserving certain demographics; supplier bias, where AI might favor large chains over diverse suppliers; and seasonal or geographic bias, where the model might miss local community health needs. To meet those three ethical AI goals, for fairness, I ensure recommendations don't reduce medication access for vulnerable populations and include a lot of diverse supplier options. For accountability, I maintain decision audit trails, always follow the pharmacist override, Conduct regular performance monitoring. For transparency, I provide explainable recommendations, general methodology, easy feedback mechanisms for reporting issues. The key principle here is that AI augments rather than replaces pharmacists' expertise. The pharmacist always remains ultimately responsible for all inventory decisions. For training strategy and key takeaways, from a user experience perspective, we created a system that reduces daily inventory tasks from, maybe 30 minutes to just 5 minutes while maintaining pharmacist control and decision-making authority. The intelligent defaults learn from pharmacist preferences, and transparent operations ensure users understand and trust the AI recommendations. From privacy and ethics standpoints, we built comprehensive regulatory compliance into the foundation, addressing HIPAA, state pharmacy board requirements, and modern privacy laws. We proactively identified potential bias sources and implemented systematic mitigation strategies rather than waiting for problems to emerge. Most importantly, this demonstrates how AI can enhance rather than replace human expertise in healthcare settings. Pharmacist remains the ultimate decision maker, but now has data driven insights to make better, faster decisions. This approach builds trust while delivering measurable business value through improved efficiency and reduced errors. Thank you. Have a good evening.